Hi, my name is Henry Lee. For the week 10 video, I'm going to be talking about limitations on large language models. As always, I'm going to be basing my video on another YouTube video, and this YouTube video is made by the channel ARC Price, and it is titled General Intelligence, Define It, Measure It, Build It. In that video, a speaker, Francois Cholet, if giving like a presentation on artificial intelligence, and he's a famous software developer and AI researcher, and he has worked for Google in the past, and he's the creator of the Keras deep learning library. In his presentation, he mentioned about the five limitations on large language models. And these five are hallucinations, inability to differentiate from memorized patterns, extreme sensibility to phrasing, inability to solve trivial problems that are unfamiliar, and lastly, weak generalization. Um, since we already covered hallucinations in a past video, I'm just gonna like briefly explain it, I guess. And basically, to recap, hallucinations is when the LLM doesn't have enough knowledge to make an answer, but it will still try you to get an answer. So even though it doesn't know what it is, it won't say that it doesn't know or that it doesn't have enough knowledge. It will give you something random thinking that it is correct. It doesn't, because the LLM doesn't know, doesn't reason. It just like compares knowledge from his database. If it's not there, it will try to get something out of there, even though like it is not close to it. So it would just give you random nonsense because it doesn't have the data. And next, we're gonna be covering like inability to differentiate from memorized patterns. And and this mainly deals with this like common riddle that many people heard. Like my science professor or teacher also like asked us this question or like a variation of this. What's heavier, 10 kilos of steel or 1 kilos of feathers? And during the early days of the release, ChatGPT answered that they're the same. Like, what's heavier, 10 kilos of this or 1 kilos of this? And the reason why it answered them the same, even though like it's obviously wrong, is because like it matched to the common riddle, the common variation where like it's only 1 kilo of steel and 1 kilo of feathers. But in this one, we added like an extra zero, so making it 10. And basically what the machine did was it mostly compared it. It said, oh, this looks familiar without looking at the numbers. And that's why like it like it incorrectly gave an answer. And this was somewhat patched. So if you ask this, it will give you the correct answer, but there's still like other ways to get them or like to confuse the machine if you try hard enough. The next limitation is sensibility to phrasing. And in the video, Cholet like gave us like a prompt or like a statement for any LLM. For any query that seems to work, there exists an equivalent rephrasing of the query readily understood by a human that would break. In other words, like if there's a query that works, there's also a similar rephrasing of the same query that makes it break. And basically what this means is if you change a name or a number in a prompt that you already ran, you could risk breaking it this time just by like changing a name or like a number. You don't change like the overall structure or anything. You just simple variables, and it will break it. And the reason why this is happening is because the LLM is slowly deviating from its memorized data. Like as we learned from the past um, bullet point, basically that it cannot deviate much from the memorized patterns, and this is like the problem. Like it's slowly deviating from it. And but like conversely, like because this seems to be like two ways, like A goes to B and B goes to C, the opposite is also true. That you can improve the performance of like a prompt if you like hit the right keywords. So like yeah, extreme sensibility to phrasing. Depending on how you write a prompt, you either have like a good performance or you break it completely. And that's just simply by rephrasing. You're not really like changing anything much. And this goes like moving on onto the third bullet point, inability to solve problems that it hasn't seen before. So as you could have guessed from like the past slides, like the elements always looking at its training data, at the memorized patterns from there. And if it's not in there, like it won't know what to do, or at the very least, it will look for similar problems and try to work from it. And yeah, as I mentioned, LLMs are able to fetch memorized problems from dataset and use them as templates for the current task. And no matter how easy the problems is, like if you haven't seen it before, it won't be able to do it. So it might be able to solve a Caesar cipher using a shift tree, since those are very common, but not shift 13, because like I guess it's not in his training data a lot compared to a shift tree, even though like it's basically the same. What's it called? It's the same. It's the same steps basically. It's just like having different numbers. And as you can see in the example, a Caesar cipher using shift tree, basically you shift three positions, like from D, right? You go shift one goes to C, shift two goes to B, and shift three goes to A. So D matches or maps to A. D, as you can see, matches A. E shift three, one, two, three goes to B. So B maps to B. And this is easy, but if you were to change it to 13, like it won't know how to do it, even though like the steps are the same basically. You just like shifting more backwards. And the hypothesis that Cholet proposed in the video is that LLM performance depends purely on the task familiarity, not at all on task complexity. And I agree with that because it's not able to solve trivial or simple problems if it hasn't seen them before. And the last limitation that it has is that it has weak generalization. Even if it manages to solve trivial problems, the LLM can apply to gain knowledge effectively. And for the examples that he had, Chole had in the video presentation was that ChatGPT 4 only had a 59 accuracy on three-digit number multiplication. And in theory, if you know how to do multiplication, this number should be very high. But like it's only like being accurate like 59% of the time, like which shouldn't make sense because if you know how to multiply like half of percent of the time, you should be able to multiply the other half of the time. And I guess what this shows is that like it cannot get applied to gain knowledge effectively. And were these problems fixed? Many of these problems were already solved through point one fixes, and this involves human constructors adding examples of fixes to train the LLM on those particular problems. But this is not a good approach, as it only addresses specific situations instead of changing the overall learning process so that it won't happen again. So this is more like a band-aid fix, like it is only fixing those like particular examples and not making sure that it won't happen on future examples or future prompts. It only targets specific ones. And as always, this is what I learned or my takeaways from watching the video, which might not be accurate, but thank you.